example 1, it says 1,000 grams of a particular radioactive substance decays according to this function. Where t is greater than or equal to 0 because t is time. It's measured in years, and m is measured in grams. Okay, part A wants to know, when does the mass of a substance reach a safe level of 1 gram? So they're asking us to put 1 in for m, and this is what we're solving. Now, in order to get an exponent out of the exponent, when you're talking about an e function, you raise everything to the natural log. Well, not raise it. Take the natural log of both sides of the equation. The natural log of 1... Oh, wait, I don't want to do that yet, because that's going to wipe it all out. We're going to divide by 1,000 first. We're going to have 1 over 1,000 equals e to the negative t over 850. Then we'll put the natural log through. And the natural log and the e are going to cancel each other out. So I will just have this left. And then if I try to calculate this, I would have to multiply by a negative 850 to the other side. And that would give me t. So if I do that in the calculator, we get, and they want to the nearest year, t is approximately 5,872 years. Now part B wants us to write the mass function to the base 1/2. So they want us to change the function 1,000 e to the negative t over 850 into a function that uses 1,000 and then 1/2 to some function, some p times t. So for this one, again, we're going to put a natural log through after we divide by the 1,000. So the thousands are going to cancel. We're going to put a natural log through. This is going to be e to the negative t over 850 is equal to natural log of 1/2 to the pt. The natural log and the e are going to cancel, so I get negative t over 850. Here I can pull that p of t in front. I can also change that 1/2 to 2 to the negative 1. So the negative is going to come in front, and the p times t, or p of t, and get natural log of 2. So now I want to solve this for p of t. P of t is going to be, negatives cancel, t over 850 natural log of 2. So that means that I can write my function, instead of being the 1,000 e to the negative t over 850, it would be 1,000 1/2 to the t over 850 natural log of 2. So what does that say? It says when t increases by 850 ln of 2, which that factor is actually 589 years, the mass decreases by a factor of 1/2. So there was no calculus in example 1. It was just working with logarithms. Okay, now we're going to start doing derivatives. And the derivative rule, if you're taking the derivative of any number to a letter, its derivative is going to be the same exact thing and then the natural log of the number, which is the base. So example 2a says, find the derivative of f of x equals 3 to the x. So according to my derivative rules, it's just going to be f prime of x is equal to 3 to the x times the natural log of 3. Done. Part B wants us to take the derivative of g of t is equal to 108 times 2 to the t over 12. Okay, well 108 is a constant out in front and it's multiplied, so I can just let it tag along. And then the derivative of b to the u, or b to the x, this is going to have junk in it, the derivative of the junk. So we're going to have 2 to the t over 12. We're going to have a natural log of 2, but then we're also going to have to take the derivative of the power. The derivative of t over 12 is 1/12. Now, the reason we didn't do it in part A was because the power was x and its derivative is 1. But in this example, the power is not just a t, it's a t over 12. Now, cleaning this up, 108 divides by 12 evenly, it's going to be 9. Then I'll put the natural log of 2, and then I'll put the 2 to the t over 12. And now we're ready for example 3. Okay, so 3 is giving you a formula that incidence of Down syndrome infants increases with the age of the mother. So the formula they gave us was P of A equals 1 over, 1613000, and then 1.2733 to the A. A would stand for age of the mother in years, and P of A is the number of Down syndrome children per total births. So according to the model, at what age is the incidence of Down syndrome equal to 0.01? That is 1 in 100. Okay, so they're wanting us to put 0.01 here. And we're having this letter in the exponent again, so we're going to have to put a natural log through. But before we do it, we need to multiply by 1613000. So I end up with 16,130 is equal to 1.2733 to the A. Then I'm going to put a natural log through, which is going to pull the A in front and leave us with a natural log of 1.2733. And then to solve for A, I just need to divide by the natural log of 1.2733. And so that gives me A. Now, according to the calculations, when you put this in your calculator, A is approximately 40 years old. Part B wants us to get the derivative. Well, the derivative of P of A is going to be 1 over 1613000 times 1.2733 to the A, and then the derivative of A would just be 1, but I need the natural log of the base, 1.2733. Okay, so if I work with that, this turns into, according to the book, it turns into 1.2733 to the A. Then C wants us to find P prime at 35 and P prime at 46, which that just means you need to stick them in there. So sticking it into your answer in part B, you get 0.0007, and sticking 46 in, you get 0.01. Okay, the first one means the incidence increases at a rate of about 0.0007 births per year. By 46, it changes to 0.01 births per year.